Hello back. Welcome back, Math Scholars. Professor Rick Math here. We're going to talk about trig functions of general angles today. So we've discussed sine, cosine, and tangent with in relation to the right triangle trigonometry, review of geometry. Now we're going to talk about some other types of trig functions. So first off, before we get into all this up here, there are three other trig functions you have to be concerned with. We have cosecant, abbreviated CSC, secant, SEC, and cotangent, COT. So you can use these three trig functions also with right triangle trigonometry. As you can see, based off these ratios, which I'll get to how the ratios work out in a second, they're just simply the reciprocals of the three main trig functions. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now, the way you can remember this is, now obviously tangent and cotangent should be fairly easy to match up as reciprocals. They essentially have the same name. Now, dealing with the cosecant and secant, the way you want to remember it is that we have S for sine, C for cosine, C for cosecant, and S for secant. You can't have a double letter to be reciprocals. So like sine and secant don't match up because they have the same letter S. Just likewise, cosine and cosecant don't match up because they have the same letter C. So it has to be an S and a C. So if we're talking about sine, if we're talking about a C, then it has to be cosecant. Cosine, its reciprocal has to then be secant. Now, since we don't have to always deal with right triangles to set up these trig ratios, we're using these ratios of a coordinate point, x, y. And this point is a certain angle distance away from the origin, the starting points. And based off that angle right there is how we can set up these different ratios. Sine being y over r, cosine x over r, tangent y over x, and then obviously the reciprocals. Where r is the radius, the length of this ray that creates the angle. You find that very straightforward. It's a square root of x squared plus y squared. It's essentially a Pythagorean theorem value to find r, which is the hypotenuse really of a right triangle created, and that's where that's coming from. So r is always positive, where the x and y's can be positive or they can be negative based off which quadrant they're in. Remember, in quadrant 1, x and y are both positives. Quadrant 2, x is positive, y is negative. Quadrant 3, they're both negatives. And quadrant 4, x is positive, but y is negative. So that will mean in certain quadrants, certain ones of these ratios will be positive or negative, depending upon, again, which quadrant we're referring to. So if we want to find the exact values of the six trig functions based off a coordinate point, we're going to need to use the point first to find r. So r would equal our square roots. Oops, sorry about that. So again, r is going to equal the square root of the x squared plus the y squared. So it'll be 6 squared plus negative 2 squared. 36 plus 4, which is 40, which simplifies to 2 square root of 10. So when we set up our trig ratios, then sine is always y over r, so it's negative 2 over 2 square root of 10. Cosine, and it's of theta there, that's what that angle is, would be x over r, so it'd be 6 over 2 square root of 10. Tangent would be y over x, so negative 2 over 6. And then our reciprocal is cosecant, would be r over y. Secant is r over x. And then tangent is x over y. Or sorry, it's cotangent, not tangent. Now for each one of these we have this fraction, which means the fractions need to be reduced. So for sine it becomes negative 1 over square root of 10. And if we remember our rules of radicals, we can't have a square root in the denominator. So we multiply by the radical 10 to rationalize and get radical 10 over 10. Cosine will reduce to 3 over square root of 10. Again, rationalizing, we would get 3 radical 10 over 10. Tangent, simple one, just reduces to negative 1/3. Cosecant will reduce to negative square root of 10. There's no radical in the denominator, so we don't have to rationalize. Secant would be square root of 10 over 3. And cotangent would be negative 3. So if you're asked to find all 6, that's all you're looking for, using the corner points, and then you are using the R value you found to write your fraction and then reduce it. If the problem only asks for sine or only secant or whatever, then you just simply find that particular trig function. Now, something we need to talk about is the idea of a reference angle. The reference angle comes into play when we talk about trying to evaluate trig functions without the aid of a calculator, because as you get used to these problems here, angles in the first quadrant, at least special angles, will be easily memorized, either through the tables I'm going to provide for you in a couple of slides, or when we talk about something like the unit circle in a later video. Now this down here is how we identify and find our reference angles. It's all based on which quadrant we're in, and then we're either doing 180 minus theta or pi minus theta if we're in quadrant 2. Again, remembering pi is in radians. Quadrant 3 would be theta minus 180 or theta minus pi, and quadrant 4 is 360 minus theta or 2 pi minus theta. And again, that relates the original angle back to its reference angle, pretty much its equivalent in quadrant 1. So if we have these angles we want to find the reference angles for, well, 210 degrees is in quadrant 3. And in quadrant 3, our reference angle is found by doing the given angle minus 180. So 210 degrees would be equivalent to 30 degrees. This means when we talk about finding the sine, cosine, tangent, or any trig function of 210, it will be equivalent for the number to doing the same trig function of 30 degrees. There will be a difference in terms of whether it's positive or negative based off which trig function we're referring to, but it will at least be the same actual number value, and we'll worry about the negative in a later part. Now, if the angle given to us is negative, we need to first make it a positive angle. So we're looking for a positive coterminal angle. So finding positive coterminal angles, we add by 2 pi. And adding by 2 pi is the same thing as adding by 8 pi over 4. Why do we make it 8 pi over 4? Well, in order to add fractions, they must have a common denominator. So 2 pi is the same thing as 8 pi over 4. This combines to be 3 pi over 4. 3 pi over 4 is in quadrant 2. So therefore, if we go back, it's easy to see that. Our angles here for pi is 0, pi over 2, pi, and 3 pi over 2 based off our quadrants. So if we're talking about 3 pi over 4, that falls over in this range in here. So that means we would do pi minus the given angle, 3 pi over 4. Again, if we're subtracting fractions, they have to have a common denominator. So pi becomes 4 pi over 4. We subtract and get pi over 4. For 5 pi over 3, it's a positive angle, so we'll need to find its coterminal. And 5 pi over 3 being quadrant 4. So in quadrant 4, our reference angle is found by doing 2 pi minus the given angle. If it's 2 pi, its equivalent will be 6 pi over 3. Get a common denominator, which then subtracts to get pi over 3. And then finally, 410 degrees, well, it's negative. So again, we need to find its positive coterminal angle. So we add by 360. We get a negative 150. That's still negative, so we have to add by 360 again. Well, sorry, it's on negative 150. It's just 50. That's my mistake. We add by 360 again, we get 310. That's also in quadrant 4, so our reference angle then is 360 minus 310, which is 50 degrees. So again, you're just using the reference angles chart to convert your angles from where it is to where it needs to be. Again, identify the appropriate quadrants and then use the appropriate formula based off that. So remember when I was talking about certain trig functions are positive or negative in different quadrants? Well, this is the chart that shows this. Everything is positive in quadrant 1, but in all the other quadrants, there's only 2 pairs of trig functions that are positive. Sine and cosecant in quadrant 2, tangent and cotangent in quadrant 3, and cosine and secant in quadrant 4. Again, it's all based off the x and y's, remembering that in quadrant 2, x is negative and y is positive. Well, cosine, secant, tangent, and cotangent all use x values, so that's why those have to be negative. And then sine only uses y values, that's why they stay positive. In quadrant 3, the x and y are both negative. That's why the tangent and cotangent are positives, because we do a negative divided by negative. That's where it becomes positive. And again, the other ones just use the x or the y value, and r is always positive. And finally, in quadrant 4, the x is positive, but the y is negative. That's why the functions that use the x's exclusively, cosine and secant, have to be positive, but all the other ones that use x and or y together will have to then be the negatives. Okay? Now this chart right here is just using your special y angles, 30 degrees, 45 degrees, and 60 degrees. You should recognize those numbers from geometry. We talked about your 45, 45, 90 right triangles and your 30, 60, 90 right triangles. And that's where these ratios are actually coming from. They're based off that idea. And we use this to pretty much set up any of the other special angles in our diagrams. And this is where the reference angles come into play. Because if we're talking about like sine of 150, that's equivalent to sine of 30. We just need to identify whether it stays positive or it becomes negative. So make sure you have these copied down for sine, cosine, and tangents. And also do the same thing for cosecant, secant, and cotangent. Now, if we want to find the exact value without a calculator, which is very useful, so if you go back to that list there, you see radicals. And most of your calculators will not give you the radical symbol. They'll just give you the decimal value, which will tell me that you used a calculator. So make sure you're always using the radicals. First thing, we need to identify the quadrants. 240 is in quadrant 3. So our reference angle would be 240 minus 180, which is 60. So this is equivalent to cosine of 60. Now, in quadrant 3, cosine is negative. So it's really equivalent to negative cosine 60. Alright, so then from there we just want to simply identify using the chart we just saw what is the actual value of cosine of 60, again without the aid of the calculator. And without the aid of the calculator, the value of cosine of 60 is supposed to be a half. So since it's negative, this would be negative 1/2. So that wouldn't be too bad if you accidentally use your calculator instead. You would get negative 0.5, and then hopefully you were smart enough to put it in the fraction form. For 5 pi over 6, well, this is in quadrant 2, because it's less than pi, but bigger than pi over 2. So our reference angle would be pi minus 5 pi over 6, which becomes 6 pi over 6 minus 5 pi over 6, which is just pi over 6. So we get cosecant of pi over 6. Again, in quadrant 2, cosecant is based off its r over y. So since r is always positive and y is positive in quadrant 2, this is also positive. And pi over 6 is equivalent to 30 degrees. So if we're looking for cosecant of 30 degrees, we find the answer is a positive 2. There is no button for cosecant on most calculators, so that's one that you kind of have to know that in order to figure this particular part out. If we're talking about sine of 135, well, that's in quadrant 4. It's bigger than 270, but less than 360. So our reference angle would be 360 minus 315, which is 45. So this is equivalent to sine of 45. And in quadrant 4, the sign is negative because the y values are negative. So that's why it's negative sine 45. So it'd be negative square root of 2 over 2. And then finally, tangent of 4 pi over 3. Well, that is in quadrant 3, which means our theta reference would be 4 pi over 3 minus pi, which becomes 3 pi over 3. So we get pi over 3 for the reference angle. And in quadrant 3, the tangent is positive because tangent is y over x. And in quadrant 3, both x and y are negatives, which means they cancel to result in a positive. Pi over 3 is equivalent to 60 degrees. So if we're using our handy chart, tangent of 60 is square root of 3. And there we go. Alright, so that's what I'm looking for if I'm asking you to find the general, working with general trig functions. Not too much going on there. It's pretty straightforward once you get the hang of how to identify each of these different angles, the reference angles, quadrants, all that wonderful stuff. Sorry, again. So it looks like that's it for today. I appreciate you guys watching, and that means McMath is out.